Hi there, welcome to my channel. In this video, I'm going to discuss about a solution for finding the duplicate elements within a given distance. Let's look at the problem description. We are given an integer array nums and an integer k, and we have to return true if there are two indices I and j where the numbers present in that indexes are same, and also they should be within the given distance k. So let's take a look at the example 1. So the nums array here is 1, 2, 3, 1. We have to find if there are any duplicate elements with a distance between them is less than or equal to 3. So in this case, so we see a duplicate for the number 1, and that is 3 index away from the first occurrence. Okay, so this is index 0 and this is at index 3. The distance between them is 3, which is less than or equal to k. So we have to return true. In the case of example 2, we have the nums array with value 1, 0, 1, 1, and the distance given is k equals 1. The first two occurrence of the number 1 is 2 index away. Okay, this is at 0, 1, 2. So 2 minus 0, 2, which is greater than the k. We have to see the next duplicate for the number 1. So in this case, the 1 at index 2 and 1 at index 3 are just 1 index away from each other. Okay, so in that case we can return true. Example 3, so the number 1 has a duplicate, but the distance between those two indexes are greater than 2. So this is at index 3 and this is at index 0. So 3 minus 0 is greater than 2. So we have to return false. The constraints for this problem is the array length is ranging from 1 to 100,000, and the num values are ranging from minus 10 to the power 9 to 10 to the power 9, and the value of k is ranging from 0 to 10 to the power 5. Let's look at the approach to solve this problem. So we are given the input nums array 1, 2, 3, 1. The maximum distance between the duplicates is 3. In this case, the number 1 occur at index 0 and another one is at index 3. So 3 minus 0, 3, which is less than or equal to the distance, maximum distance. So we have to return true. We can solve this using a hash map in which we can remember the most recent index of any given number. Okay, for example, when we visit the number 1, we have to store the index of that number in the index map. So if you see here 1 and its index 0, and next we are seeing number 2 and its index 1, and then 3 and its index 2. Okay, so we build this index map. So each time when we traverse the nums array, each time we do a lookup in the index map for the current number. If that number doesn't exist, we simply add an entry for that number with its current index value. Otherwise, we have to extract the index value of its most recent occurrence and its current occurrence and find the difference. If that is less than or equal to k, then we can return true. Okay, for example, in this case, first 3 numbers we build this index map. When we visit the number 1, we look up the index map and it is already present with most recent occurrences at index 0. So we pick up this number and the index of the current occurrence. When we subtract, so in this case it is 3. So when we subtract 3 minus 0, which is less than or equal to 3, so we return true. That's what I have listed those steps here. So initialize the index hash map and store the index of each number seen most recently, and we traverse the nums array, and each time we traverse we check the index map if there is an entry exists already. In that case we take the value and subtract that from the current index and check whether the difference is less than or equal to k. If so, we can return true. Let's look at the flow chart. Input for this procedure is the nums array and the distance k. First we initialize the index map and the index and the count and the return value variables. So the index is set to 0 and the count is set to the length of the input array and the return value is set to false. Okay. Then we traverse the elements in the nums array. So we check whether all the elements are processed. If so, we break out of the loop. Otherwise, we check whether there is an entry in the index map for the current number. If there is no entry for the current number, then we simply add an entry in the index map and move on to processing the next number. Otherwise, we extract the value from the index map for that number and find the difference between the current index value and the value extracted from the index map. If that value is less than or equal to k, then we set the return value to true and break out of the loop and return the return value. If it is not less than or equal to k, then we'll have to update the current entry in the index map with the index value of the current element. Okay, and increment the index and process the remaining elements. Once all the elements are processed, then finally we come out and return the root value. Let's move on to coding. First I initialize the index map, which is a map of int to int. This will contain number and its index mapping. Next I initialize the count variable with the length of the array. Then I write the for loop which traverses the elements in the input array. Next I read the number at index idx and assign that to variable n. Then I look up the index map and check whether there is an entry for the number n. If there is an entry, then I compute the difference between the current index and the previous index and check whether that is less than or equal to k. If so, I return true. Otherwise, I update the value of the current entry in the index map. Then finally I return false. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool, this program is accepted. Next I am going to do the code walkthrough with sample input. Let's do the code walkthrough for this input. So the input array is 1, 2, 3, 1 and the maximum distance between the duplicates allowed is 3. So in this case the number 1 occur at index 0 and 3. So the difference between that index is 3, which is less than or equal to the k. So the expected output is true. Okay. So first we initialize the index map, which is a map of int to int, and then we start traversing the numbers in the nums array. Okay. At iteration 0, we process the number 1 and we check whether there is an entry in the index map. It is not present, so we add an entry for that number. This is the number and its index, which is 0. Okay. And in the iteration 1, we process the number 2. We check whether there is an entry in the index map. It is not present, so we simply add an entry for number 2 and its index 1. And in the iteration 2, we process the number 3 and we check whether there is an entry in the index map. It is not. So we add an entry for number 3 and its index 2. Next, in the iteration 3, we see the number 1. Then we check whether there is an entry in the index map. There is an entry for number 1 with the index is most recent occurrence, previous occurrences at index 0. Okay. So then we extract that value and subtract that from the current index, which is 3. So 3 minus 0, 3, that is less than or equal to the value k, that is 3. So we return true, that is an expected output. Next, I'm going to do the time and space complexity analysis for this solution. Let's do the time and space complexity analysis for this case and this case. Okay. So in the case 1, the nums array has 5, 5, 3, 1 and the maximum distance between the duplicates is 3. Okay. Let's see how many iterations this for loop performs. Okay. In this case, in iteration 1, we can find the duplicates which are less than 3 indexes away each other. So only 2 iterations this for loop performs. Okay. But in the case of 2, the number 1 has a duplicates at the end of the array. Okay. In this case, we have to traverse the entire array. Okay. The number of iterations performed by this for loop is 4, which is equal to the number of elements in the array. So in the worst case scenario, if there are n elements, then in the worst case, this for loop needs to perform n iteration. So the time complexity is order of n. The space complexity depends on the unique numbers in the input array. Okay. For example, in this case, in the case of case 1, we just need to store only one entry in the index map, because in the iteration 1 itself we find the duplicate, so no need to add the rest of the numbers in the index map. But in the case 2, we need to add all the 3 numbers and finally we figure it out. So worst case scenario, if there are n unique numbers, then we have to store n entries in the index map. So the space complexity is order of n. Thanks for watching this video. Have a great day.